All right, let's get started. Good afternoon. How's everyone doing? All right, awesome. My name is Peter Rabbeni. I'm the Vice President of RF Solutions here at GlobalFoundries. I'm really excited to talk to you today about our technologies and offerings and solutions within the infrastructure space. I think it's very exciting to understand, some of the changes that have happened in this space, particularly as we start to see the rollout of technologies like 5G, and really talk to you about some of the things that we have to offer there. I want to try to leave you with three key messages here as you look through our presentation. One, certainly 5G is a technology that is here, and as we look at the rollout of systems and infrastructure in the marketplace, that's happening today, and we see that with a number of customers, and we'll show some examples of those. Second thing I want to leave you with is that the choice of technology, particularly in infrastructure, is really critical in terms of determining CapEx and OpEx expenditures. And that's not, maybe you can't make the connection there yet, but as we go through and you see what some of the trade-offs have to be in terms of what customers that are operating in this space have to make, it becomes evidently clear as to how that equation closes. And then third, last thing I want to leave you with is that GlobalFoundries is delivering solutions today. We have over 20 plus customers leveraging our technologies to create devices that are going into this space and delivering on this market today. So let's get into it and talk a little bit more about what we have here. So talking about the market, 5G has evolved from theory to reality, and that's very true today. As we look at how 5G is launched, particularly in South Korea and here in the United States, networks are rolling out. Infrastructure is rolling out both on the CPE side as well as a base station type of market across the world. And we've seen, with the evolution of the various standards and the improvement of the standards over time and the introduction of various features within the standard, we see that rolling out over time and being able to serve the type of markets based upon the type of spectrum that's available in the various countries of the world. What you're going to find is that some areas, particularly in China, they're rolling out things like sub-6 gigahertz. Whereas here in the United States, because of some of the spectrum allocation and some of the interference challenges that are with some of the congested area below 6 gigahertz, mmWave has really emerged as the play, particularly here in the U.S. But nevertheless, as we start to see the rollout of 5G, it is here. It is here, and we are seeing customers develop and launch solutions into the marketplace here today. So what we see is there's over 16 plus major markets worldwide that are delivering on this technology. I want you to take a look at this CapEx number. Mobile operators are expected to expend about $160 billion in terms of being able to roll out these networks and deliver to consumers on the promises of what 5G is. And certainly as we look at those expenditures and trying to help our customers or your customers in being able to deliver those solutions is to try to deliver not only the lowest cost but the best performing solution in the market. And finally, as we look at what 5G promises to bring, and we look at the various industries that can leverage the benefits of 5G technologies, really adding to the global economy in terms of revenue streams and various types of applications. So. How many of you have sat on the tarmac at SFO and tried to download that latest Elvis Costello album just before you get to go to Shanghai? Okay, that must be just me. It's Peter problem number one. But I think perhaps you're aware of the congestion in sub-6 gigahertz and what the technologies in 4G and LTE have tried to deliver. And clearly today that as more and more users try to bring new devices onto the network, we see the congestion and that today's networks just really can't handle. And really, what we want to have is the ability to be able to have the bandwidth to explore, to not only have the type of communications and data delivery that we want, but also enable other types of applications. Who would like their liquor cabinet to be able to order their gin bottle once it's empty at the end of the day? Okay, Peter, problem number 2, I guess. But clearly one of the things that will give rise to 5G is the concept of interconnected devices. The whole concept of IoT and being able to have all of these devices connected to the internet and tied to this whole concept. Everyone's talking about AI, but the ability to think about the amount of applications that we can't even fathom at this point in time, where you have each of these devices that we carry with ourselves that have sensor capabilities and can collect information about ourselves, our environment, and be able to leverage AI to bring a better experience and service to customers. Let's maybe bring it down to a little bit more reality in terms of some of the applications that can potentially be used. Think about the ability to be able to monitor the humidity, environmental conditions, the soil conditions in, say, a farm in the middle of the desert of the Middle East, and now aggregating all of that information, using that information on growth profiles and environmental conditions to be able to use that information, collect that information, and be able to potentially use that information to drive models and analytics to create agriculture in other type of arid environments, and using that to generate new business models. How about the ability to be able to monitor your son or daughter's sugar level while they're at school, and be able to remotely be able to administer a medication in a time of need. These are some of the things, some of just the concepts of things that'll be enabled by 5G. And as we look at where the market is growing, where the market is headed in terms of the capability and capacity that this technology will bring, predictions of over 1 trillion devices in 2035 leveraging 5G networks. Although I would fathom to say we're probably in 6G by then. Who knows what technologies we'll see in the future. So as I said, 5G deployments are happening today. We see that across the world. Like I said, here in the United States, there's been a number of select areas within the U.S. that have been selected for 5G deployment. U.S. and Asia seem to be leading certainly leading the deployments with Europe close behind. And over time, we will continue to see the deployment of these technologies worldwide in various spectrums. As I said, we're seeing a number of countries, developing or deploying sub-6 gigahertz, and other countries developing and deploying mmWave. So again, we're talking about both sub-6 gigahertz and mmWave, but certainly in terms of delivering the speeds and the capacities that are going to be needed for these various types of systems, it's going to add a good amount of complexity in terms of being able to deliver the type of systems that will be needed in both of these type of areas. So, we see sub-6 gigahertz 5G being farmed into different bands within the sub-6 gigahertz regime of spectrum. But that area, as we talked about, we just spoke about, is very congested. And clearly one of the areas that is being looked at in order to be able to augment the sub-6 gigahertz spectrum is being able to deploy also mmWave. So we see, or it is planned that millimeter wave networks will be able to leverage the sub-6 gigahertz spectrum in order to set up and tear down services to enable 5G. And what we tend to see as the type of applications are some of the some of the last mile, very high bandwidth, very high speed type of connectivity solutions that not only require the very large bandwidth and high speed, but also the low latency that millimeter wave can bring. And these technologies, as I said, will give rise to various types of applications that we can't even fathom today. And it's very exciting to think about what those applications could potentially be and how Silicon Solutions can bring about those types of solutions in the future. So giving a little bit of the complexity, giving a different perspective on the complexity, if we look at today's networks and how today's networks operate, basically 4G network, 4G LTE networks, basically blast in every direction. They blast energy isotropically. Hopefully the network was designed in a manner such that you can get that signal from the base station, and you can communicate. You can make a call. But that's not very optimized. As we get into millimeter wave and the higher frequency bands, it's not enough to be able to transmit isotropically. It requires way too much energy in order to be able to do that. And really the focus in order to be able to deliver the highest quality of service, the best power, is really to utilize what's called phased arrays. And that is really the secret to being able to leverage tomorrow's networks, particularly in millimeter wave. And we see that in order to create these targeted beams of energies to users and groups of users, that it will require a different level of complexity and enablement from a technology perspective, not only from say the silicon side, but also the software side in order to be able to control this. So, when we look at it from that perspective, it's not just silicon technology, but it's silicon technology coupled with software that controls the digital enablement or the digital control that these networks have to be under. And I want you to think a moment about how AI comes into the picture of some of these. So now think about these beams of energy being controlled based upon the sensors in your phone. As you move location, as you move to a different part of a city or the home, those sensors send back information back to the network, and the network optimizes the signal delivered to the user. So there's a lot of use cases here that are still yet to be discovered and investigated, but the excitement is really there, and really having a technology or a set of technologies that can combine best-in-class performance from an RF perspective, radio perspective, as well as from capability from a digital integration perspective is very, very, very key to enabling these networks. So, how do we, what are the key items that, we kind of talked a little bit about this. What are the key items in terms of trying to tackle today's 5G challenges and complexity? Well, we talked a little bit about coverage, right? We already talked about coverage. Coverage is going to be a key element of being able to deliver these 5G networks. And that really depends upon, having the right efficient and being able to deliver very efficient high TX transmitter power and receiver sensitivity. And both of those really play into being able to either make a call or receive data reliably. The second is having broadband capability within the device. Being able to receive or transmit on a broadband network and then be able to process that data for the user. And then finally, all this has to be done efficiently from a power perspective. You don't want to be able to turn on your 5G radio in your phone and then have the battery die out after a half hour of use. So all of these are very key to being able to deliver on the promises of 5G. So if we look at, we talked a little bit about phased arrays, and I talked about the complexity. some of the example art, or one of the example architectures that we're seeing here is a way to potentially solution a phased array system. And really it comes down to the elements that you see here, really having a phased array antenna subsystem that is fed by what we call a beamformer. And that beamformer can take a number of different architecture instantiations. In here we show one that's called hybrid beamforming that combines that helps combine a portion of analog capability and digital capability together to deliver an optimized solution. And really, from an infrastructure perspective, one of the prevailing methods to potentially solution infrastructure 5G, particularly for millimeter wave. Having that beamformer, being able to take the RF or millimeter wave signals down to bits, having the capability to be able to process those very high-speed signals down to bits, and then having a very high-speed DFE or digital front end that can take those bits, post-process that, and then deliver that information to the baseband for further number crunching by for the user. So all of these different elements that you see in this architecture require certain subsystem blocks that have to be optimized in order to support this type of architecture. So if we look at the beamformer and we look at some of the key elements here, certainly you need a PA with very high efficiency. To deliver, PA, to deliver high output power in an efficient manner. You need a low noise amplifier to be able to receive those signals, have very low noise in order to be able to in order to extract the signal out of the dead zones. And then finally, switching is an important aspect of beamformers. We've seen that, particularly in the sub 6 gigahertz regime with front-end modules. And being able to integrate all of these elements together into a single chip so that they seamlessly work together as a signal unit is very, very important. And also having that capability under digital control is a must. If we move down and look at the rest of the beamformer, you need to have a way to get those millimeter wave signals down to a usable frequency where you can do that post-processing. You need mixers, you need a phase lock loop, and a VCO, as well as an ADC and DAC to be able to do all that post-processing and get you down to bits. And then finally, you need that DFE at the end, the DFE in the baseband, in order to do all that digital post-processing and deliver all that information to the baseband. So this is just kind of a very high level instantiation of some of the architecture blocks that will be looked at if we as we look at 5G millimeter wave and how that'll apply to the infrastructure space. So now if we now take that information and look at what are the key items that really you need to focus on in terms of being able to deliver an energy and cost-efficient phased array system. It really comes down to two things. One is delivering the highest Pmax at the most efficient level that you can per element. And the second is delivering the lowest noise figure per element. And when we look at if we look at a phased array and we look at the aggregation of all these elements in a phased array, each of these elements doesn't have to deliver as high of a power, let's say, as say in 4G LTE, but in aggregation, as part of the architecture of a phased array and the operation of a phased array in being able to deliver that power, that's really what happens here. Is that you essentially sum up the power of each of these antenna elements to create the energy beam that's created by a phased array. The same is true for noise figure. All of these elements add together in terms of delivering the best noise figure possible. And so the more elements that you have in this phased array, obviously the higher the power, but of course the higher the cost. All right, so being able to optimize size of the array versus each of the power of the individual elements is a trade-off that designers have to make in terms of being able to create the most cost-efficient phased array. So these two elements are very, very key in being able to deliver the lowest cost solution from a phased array perspective. So we talked about, and Tom talked about this this morning. From a technology perspective, it really comes down to looking at how does one deliver on the promises of 5G from a technology solution perspective, and it really comes down to what Tom talked about this morning on this innovation equation, and that's no more or no less true as it relates to 5G infrastructure. So platforms. Technologies like 45 RFSOI and 22 FDX and others are platforms that we've delivered and created what we call application features. Things like very low loss back end of line, very high performance power amplifier devices, and really then coupling that with some of the services and the IP that we deliver as a foundry above and beyond just wafers to deliver specialized application solutions to our customers. We're going to talk about these in a little bit more in depth as we go through some of the roadmap elements that we have for this particular space. So if we now look at a base station and look at some of the areas before that we discussed, particularly if we separate the base station into basically a radio unit and a digital unit, we see some of the technologies and solutions that can be used to deliver on some of the application elements here. So if we look up at the top and see the radio head, some of the technologies and solutions that we have in being able to formulate some of the solutions for the front-end module and transmitter subsystems, things like 45 RFSOI, coupling that with high voltage PA FET that can deliver not only on the power performance, but also on the efficiency that's needed, as we talked about earlier. For even higher power systems, where you absolutely have to have the type of the necessary power that's needed for some of these systems that have to deliver very, very high, effective isotropic radio power, things like silicon germanium high performance, things like our SiGe 8HP and even SiGe 9HP technologies that can deliver very, very high power with the high performance HBT that we have enabled in these technologies. If we now move into a more integrated type of solution where we might want to combine RF with digital, we now start looking at technologies that integrate full conversion into the radio. Things like 22 FDX that also have a low loss back end of line, integrated RF switch, and the ability to do stacked PAs as well. Data conversion subsystems, so our 12 LP. Now we're getting into an area where we must have not only high levels of integration, very, very highly integrated lithography, but also the capability for very high speed. So being able to have a technology that can deliver on very high performance data conversion and digital integration in the same type of technology. So things like 12LP, not only being able to deliver on ADCs and DACs, but also on the digital subsystem of high performance infrastructure for 5G, particularly where you have to integrate very high levels of or high amounts of memory. Many of these 5G subsystems have to have things like lookup tables. In particular for doing things like digital beamforming. So having on-chip memory and the capability to be able to leverage that memory on chip is a very, very, very important aspect, and being able to couple that with very high density logic. So those are some of the systems that there are solutions that we're going to talk a little bit about here more in depth as we get into the radio. So now, if we now go back to the architecture that I showed you before, and we overlay the technology solutions that can deliver on this architecture, we see this figure here, and it really the choice, as I said, the choice of technology comes down. It's not really a one size fits all. Much of it depends upon what the customer or client is trying to achieve. What type of performance metrics he's trying to hit, as well as some of the cost targets that the customer is trying to hit as well. So, we show here several ways to slice this. So we see, particularly for the beamformer, if we're doing, say, a standalone beamformer, depending upon where it's located, utilizing 45 RF-SOI or silicon germanium HP to deliver on that solution with a full 12 LP FinFET backend that integrates ADC DAC and baseband all together. Another potential solution could be leveraging our 22FDX technology, a highly integrated, fully depleted SOI technology that really can, with its high density capability, can integrate both the front end as well as the data conversion and DFE subsystems for a 5G mmWave solution. And then finally, our 12 LP solution, again, leveraging that technology to do highly integrated digital logic as well as integrated memory, all on a single chip. So from here you can see some of the technology solutions that we as a foundry at Global Foundries have in our staple of technology portfolio that can provide very high flexibility in being able to solution the type of systems that you're looking at today, particularly for infrastructure. So if we now compare, you might be thinking, okay, well, how do I go about and choose some of these technologies? And if you look at some of the key metrics that customers may think about and maybe trading off against one another in terms of trying to see, where might I land in terms of some of the partitioning, some of the technologies that I might have to do trade-offs from. And it really comes down to, and this isn't meant to, of course, not be comprehensive, of course, but look at some of the key metrics that customers are looking at. Things like, achieving max transmit power per element, receive sensitivity, achieving energy efficiency, integration, and then also leveraging the IP ecosystem. Certainly, from each of these metrics, you can see what some of the trade-offs may be in terms of choosing one of these technologies as a solution for your infrastructure application. Our competition, or our competitors out there, may be telling you, well, just use bulk. And really, when you look at some of the performance metrics that we've seen in the marketplace and some of the papers that have been delivered, and some of the disappointments that we see, from our customers that we talk to, is that bulk just does not measure up. It does not deliver on the type of performance that's needed. Clearly, from an efficiency perspective, it is not an ideal solution. And really, we believe we have the only portfolio in the marketplace that can deliver on the promises of what 5G is meant to create. So, CHP, 45 RF-SOI, and 22FDX as those solutions that we believe deliver on the promises of 5G. So let's start talking about some of these solutions. So 45 RF-SOI, this is a technology that was actually born and bred out of the gaming processor space, believe it or not. So this is a very good example of a technology that had lived its lifetime in the digital space and was transformed into a solution to address mmWave. And this is a technology that, thanks to institutions like DARPA and many of the university partnerships that we've had over the years, as well as some of the customers that believed in this technology in its early days, really transformed this technology into what we believe is a leading solution for 5G millimeter wave. So a technology that delivers on the performance, on the levels of integration that it can achieve, being able to deliver on time to market as well because of the enablement that this technology has, and the continued innovation that we drive within not only 45 RFSOI but also our entire roadmap as it relates to 5G and millimeter wave and RF in general across the entire portfolio. So you can see here some of the metrics and some of the key performance delivery that this technology has brought. We've demonstrated plus 23 dBm PSAT with this technology at 40% power out efficiency. There's no other technology in the marketplace that can deliver on this type of performance for this type of application. Integration. We talked about the ability and the need to be able to integrate PAs, LNAs, and switches all in the same silicon. When we talk about millimeter wave, it's not sufficient to have discrete types of solutions in this space. The losses that are incurred by having a discrete type of solutions are not tenable. In order to provide the most efficient solution, you really have to have all these devices integrated into a single chip, and that's what this technology delivers. Time to market. One of the things that we really pride ourselves, and you'll see this throughout some of the presentations today, is our ability to be able to deliver to our customers a very comprehensive, not only PDK and set of models that are very, very well characterized and leverages our experience in this space over a number of years, but also our investment in test and packaging services. And I'll talk a little bit about that is specific to this particular market segment. And then finally, innovation, continued innovation on these technologies in order to deliver for our customers. So let's talk a little bit about some of the challenges. If we look at, in particular, for 45 RFSOI, we discussed things like analog hybrid beamforming and some of the requirements here. So we talked about the beamformer, obviously. This requires phase shifters, PAs, LNAs. You have to have a single transceiver and data converter control over multiple front-end modules within this type of solution. And you really need a solution that delivers on some of the state-of-the-art that is being created today for phased arrays. But the key challenge here, and we talked a little bit and touched a little bit upon this, is in order to achieve the millimeter wave PA efficiency, you really have to minimize the losses on chip. And really, it goes back to my statement earlier, being able to integrate the PA, LNA, and switch all into a single chip is really key. When it comes to linearity, the PA has to be able to operate in back off in order to be able to support the type of modulation schemes that are required for this particular space. So the higher the linearity performance in terms of output power, the better the linearity performance that I can achieve with my solution and being able to operate at a higher output power. And then finally, if we don't have that efficiency, is that we start to run into an issue. And remember, when we look at these phased arrays, each of these phased arrays have a separate PA for each of the different antenna elements. And if you operate at very low efficiency, you're throwing out a lot of that power as heat. And each of these devices in the array now begin to start to thermally couple to one another and affect the type of performance of the array. So low efficiency actually is a detriment to phased array implementation because you have limited space that these phased arrays have to operate in because of the wavelength. and you must have to maximize that efficiency in order to get the type of thermal profile that is required to not only provide the type of performance, but also provide the type of reliability that's needed. And we'll talk about that. We'll talk about it in a moment. So I kind of hinted at this a little bit earlier. FET stacking is an ability in this technology that we've been able to enable, and delivers on the type of performance. That's really the name of the game in SOI. The ability to be able to stack and reliably provide the type of power and efficiency that's needed over other types of approaches, such as power combining, which tends to be very, very inefficient and an inefficient way to be able to deliver on the power that's needed for these types of systems. High-res substrate, so we build this technology on trap-rich high-res substrates. Trap-rich high-res has the inherent capability of high isolation, low capacitance to the substrate, and has the ability to be able to deliver on very high performance back end of line copper layers that we also integrate into the technology to give you the ability to do very, very high performance discretes, leveraging the enablement that we deliver with our technology. So being able to do spiral inductors, MIM caps, and things and transmission lines, all on the same chip that are needed for millimeter wave operation. And then finally, the exceptional FET performance at millimeter wave, fully characterized up to 110 gigahertz that we deliver as standard as part of our PDK. So we touched on reliability, right? So if we're really trying to optimize an array for size, right? We're going to try to push that PA output power pretty high, right, per element. We want to get the highest output power per element so that we can get the smallest array possible in that technology. A designer really needs to know and understand how far can he push that device. So having reliability models, being able to understand the reliability of the device under certain conditions is really, really important. And we know, particularly in the infrastructure space, that these devices are going to be put on a tower somewhere in 120-degree heat in some cases, and it's really important to understand what the reliability of these devices under those conditions under those conditions may be. And certainly, being able to deliver that to the customer and have your customer, in this case the operator, understand what that means to them from an OpEx perspective, because they want to be able to understand when can I expect the mean time between failures of this device to be, and be able to predict that. So being able to give a very confident answer to your customers in delivering a reliable solution for 5G is key to being able to win them over. So it comes back to one of my second statements here, is that the choice of the solution has a direct impact on your customer from both a CapEx and OpEx perspective. So keep that in mind. So we've spent a lot of time at GlobalFoundries, really focusing on this particular element of enablement of 5G infrastructure, really helping to understand what the ruggedness, the aging, the lifetime predictions of our technologies, particularly for this space, is really important, because these devices do have to operate at high output power. They will be under extreme conditions in terms of thermal performance, and we have to understand what the self-heating element, the self-heating component of the reliability is, and be able to model that carefully, and then also understand what the substrate dependence is as well, as it relates to the performance of the technology, and being able to leverage, actually, and we'll talk a little bit about this when we talk about 22FDX, leverage the active back bias capability in the technology to adjust the performance of the technology over time, being able to do self-monitoring and be able to use that capability to be able to adjust performance. So that takes me to my next solution here, 22FDX. There is no other technology in the industry today that has the level of integration, that has the type of millimeter wave performance, has the type of enablement in order to be able to solution very highly integrated single chip SoC 5G millimeter wave designs. This is a technology that combines power performance, integration, optimized RF, and low cost in order to deliver into the 5G space. So we've demonstrated high P out PA performance, up to 50% more performance than competing technologies. In this case, a bulk CMOS. Very high integration. As I said, this is a 22 nanometer technology, so leverages the capabilities of 22 nanometer lithography to be able to integrate high levels of logic. Optimized RF, we've leveraged our best-in-breed capability and long-standing capabilities in doing RF characterization and RF modeling to bring that same capability to 22 nanometer. And then cost profile, delivering it's not just a game of wafer cost. The cost really needs to be understood at the die level, and what the advantage the technology brings at the die level, and being able to achieve the type of cost profile that's needed for the market. And we've been able to demonstrate that in comparison to other competing technologies in this particular space. So let's talk about application and challenge. Obviously now as we start to talk about high levels of integration, we now start to think about the ability to do digital beamforming. And again, the idea is to be able to integrate high levels of integration not only on the RF side, but be able to combine that with digital logic and digital control. So. As we said earlier, each of these devices in a phased array has to fit between, each of the lattice spacing in a phased array. And if we look at some of the frequency bands today, I think we're talking about somewhere between 3 and 5 millimeters between spacings. So having a chip that can deliver, can sit very reliably and efficiently within that space, and be able to deliver the type of performance that this technology brings is really, really important. So 22FDX, as I said, exceptional millimeter wave performance, the ability to integrate, high levels of logic combined with very, very high performance RF and millimeter wave, very high density capability from a logic perspective, integrating logic for ADCs, digital filters, and even SerDes. And then one of the beauties and one of the trademarks of this technology is the active backgate bias, which not only allows you capabilities to control the device over time for things like reliability, but also to utilize that backgate bias to be able to optimize the performance of the device for various types of conditions and situations. As we talked about earlier, if we look at the overall concept of the integration of AI with network control, this is a beautiful capability, quite frankly, in order to be able to leverage that control of the device and place it under software control to optimize the performance of the device in the network. So let's talk about silicon germanium HP. So there is by far if you are looking for the best RF performance at millimeter wave, nothing really beats silicon germanium HBT. It combines the high performance of a bipolar device, the ruggedness of a bipolar device, with a level of integration that Doesn't quite necessarily match what we can achieve in 22 and 45, but a sufficient amount for those types of solutions. Again, those types of solutions that can live with a minimal amount of digital logic integration, yet still be able to leverage the benefits of a CMOS technology. So, highest FT, Fmax, HBT in volume production today are, that technology is 9 HP, but today in particular in this space, we're delivering on technologies like 8 HP, 8 XP. Optimized technology solution leveraging copper backend, as we talked about earlier, for the back end of the line to be able to optimize on things like passives and transmission lines. A very complete suite of enablement with a mmWave enabled technology, not just on SiGe, but also on our other technologies, being able to leverage some of the capabilities that we developed specifically here, actually, as part of our SiGe silicon germanium technologies across our portfolio. And then, we are the de facto standard when it comes to silicon germanium development. This is a technology that was born and bred at GF through our acquisition of IBM, and really we continue to see that technology as a proof point for future development as we get into the terabit space. And you'll see more from us in that area as hopefully when we talk again next year. So SiGe HP is optimized to deliver the highest silicon mmWave PA out. As I said, some infrastructure use cases require this transmit power requirement. Very high output power per element, particularly as we start to talk about azimuth only type of solutions for fixed elevation links. And really delivers on the high effective isotropic radiated power that's needed by a given base station solution. And as I stated before, a silicon germanium HP device really delivers on the type of breakdown voltage and high performance for efficiency and power of any technology. And you can see, in terms of some of the performance that we see here, we've been able to demonstrate 28 dBm saturated output power at 28 gigahertz. Again, through our partnerships with both universities and customers in demonstrating some of these capabilities. Because of the copper back end of line and the performance that we've and the innovation and engineering that we've done on the back end of line, being able to deliver on a very optimized back end of line subsystem that you can do a very unique passive design with this technology. So SiGe HBT is a very rugged device. So provides the reliability that one needs for these systems, depending, of course, upon the couched with the fact that there are certain systems that require very high output power. So for those highest output power systems, SiGe HP really delivers on that. Finally, talk about 12LP, and now we start to get into the DFE and the digital radio unit, and really here what you need is a combination of very high levels of digital logic integration, as well as the capability to integrate very high speed performance at low power. So 12LP, delivers on the performance aspect, better than 75% higher than performance than 28 nanometer bulk CMOS. 60% power reduction, clearly operating in the gigabit sampled systems. You really need very low power for the ADCs and DACs in order to deliver on the performance that's required. Cost profile up to 55% area reduction. And 2x output increase per 2x output power increase per wafer in terms of die quantity over 28 nanometer, because of the scaling. And then being able to leverage the multi-VT capability of the technology to really optimize the solution for this particular space. So leveraging the different features in the technology to be able to deliver on the type of integration and performance that's needed in this area. So again, an application and challenge in this space. If we start to look at really what's the core of the system is really the ADCs and DACs that can take the analog RF signal, take that information, and really deliver that down to bits. You really need, very high performance data converters and digital front end and logic, and being able to do that efficiently from a power perspective, and that would again translate into capex investment by the operators in terms of delivering a very power efficient solution. So it really requires a technology that can deliver on the computational capabilities that are required by 5G. And if we look at some of the requirements of the subsystem, particularly in the area of not only ADCs and DACs, but also in the integration of SRAM. We talked about earlier that many of these subsystems are going to require a very large array of lookup tables in order to do digital beamforming and also be able to act upon some of the data that is received from the network. So we want to be able to have very small SRAM bit cell size. To be able to do the integration, you need a very high density logic library in order to deliver on the digital logic integration. Very mature manufacturing. This is a technology that has shipped well over 800,000 wafers at Global Foundries. Very high density logic that we just talked about, and then core IP. And in this case, in particular, having the access to things like high-speed SerDes in order to do digital transmission of that data back to the mobile switching center. So. End-to-end solutions. If we look at, step back and look at what GF delivers, it's really a full suite of technologies and solutions for this particular space. Whether we're talking about 45 RF-SOI to do FEM-optimized systems, whether we're talking about really going after very high power type of solutions with SiGe HP, very highly integrated RF and digital into a single chip with 22FDX, or that back-end system where you need to integrate very high levels of logic and SRAM into a single chip with our 12LP solution. Now, one thing I want to talk about is turnkey. One of the things that we recognized some time back is that it's not enough as a foundry, particularly of specialized solutions, where you don't have your own internal capability from a test and characterization perspective. You really need to have the capability to be able to characterize those technologies for your customers and provide that type of information in order to show proof points to your customers to help them make that decision and make that transition into selecting the technology. So we started a long time ago in being able to build capabilities and being able to build expertise in this space, and transition that into the delivery of what we call turnkey services. And it's no more or no less important in this space because of the challenges associated with delivering on millimeter wave type of solutions. This stuff is actually hard. It's not trivial. And having a very close relationship, having a close contact with the foundry and being able to understand the characterization of not only the devices but the technology itself, being able to deliver in these spaces is really important. So we provide turnkey services in where we actually deliver not round things to customers, but we deliver actually fully tested and characterized parts to our customers, packaged parts to our customers. They send us a GDS. We send them a package tested chip that they basically put on their board. And that's a unique capability that we believe we have in the industry. And this is something that's been perfected over 20 plus years. And we'll talk a little bit more about that. What does that mean to you? It means that you can basically simplify your supply chain. No longer do you have to get embroiled in being able to find an OSAT, being able to find a package, being able to find and develop a test solution for your chip. You come to us. We'll work with you. We'll have our engineers, our packaging engineers work with you. Our test engineer to decide on a package. You'll work with our test engineers, with over 20 plus years of experience in being able to do mmWave test using our proprietary type of solution, and deliver a total capability to you that basically allows you to be hands-off in terms of really being able to find and put together that solution for yourself. Today, obviously, we're talking about wireless infrastructure and satellite communications, of course, as it relates to 5G mmWave. But there are other mmWave applications out there, of course. Things like automotive radar and automotive LiDAR as some of the applications, as well as IoT, in particular things like mmWave gesture sensing. And these technologies can be applied in those spaces as well. And we can take those turnkey services and be able to apply those services to all these other spaces as well. And we are involved across many of these markets with various customers, and have engaged across these technologies with these customers in these services in this services portfolio. And we'll talk a little bit more about that. So as I said, we offer a full range of services in turnkey, from supply chain fulfillment, where we can manage the supply chain for you, depending upon whether you utilize our OSATs or your OSATs. Being able to deliver packaging services and leveraging some of the capabilities that we've developed on the mmWave side, and then also RF test. And really, that's where we feel that our benefit comes in, and our value proposition comes in the capability that we've developed over the last 20 years in delivering RF test solutions for our customers, all the way on up to 86 gigahertz. And you can see, from this slide, some of the various applications and market segments that we've engaged in delivering these RF test solutions. So, some of them certainly, span down below sub-6 gigahertz. But if we start to see, some of the emerging application areas and customer devices that are really driving the need for some of this, much of it is in the 5G and phased array space. And the reason why, again, this is not easy. It's hard. It requires, partnering with someone with the experience and capabilities in this space, really an area that we have invested in for some time. And the customers who have engaged us have been extremely pleased with the type of services that we offer and the type of expertise that we bring to the table in this space. So I encourage you, if you are in this space and developing a solution in this space, please come to us. We'd love to talk to you about the capabilities that we have, not only from a technology portfolio perspective and solutions perspective, but also in delivering a final product to you that you can be assured is not only reliable, but fully tested and characterized. So I talked about our capability, our 20 plus years of expertise in this space, and it really comes down to not just working with some of the standard solutions that are out there in the marketplace that you see on the right-hand side, but really perfecting what we call tester on board capability that you see on the left. This is a proprietary solution that we have developed and really optimizes for our customers and has the flexibility to optimize for our customers test time and test suite that we can enable and tailor for our customers in this space. Extremely cost effective. We will work with you in installing this solution at your chosen OSAT. And we have multiple relationships across the industry with various OSATs that we have worked very closely with in this area. So we're very, very pleased and very excited to bring this technology and capability to the mmWave space. We highly encourage you to take advantage of this capability at GF. So as I said, turnkey, we deliver a full suite of solutions from helping to select a package. You can work with our packaging engineers to design and develop the type of package that you need. Work with bump house and OSATs to do wafer bumping as well as wafer probe. Do the assembly of that device with the package, deliver that to module test, and optimize the module test for your particular solution, through production. And then even support final assembly for things like tape and reel in order to deliver on solution and deliver the finished goods to your customers. Finally, I just wanted to quickly talk about the ecosystem. No technology platform or solution is really complete without a set of partners. And hopefully you've had the chance to talk to some of our partners that are in the ecosystem next door behind me, and really speak to them about what they bring to our portfolio from a additional value added perspective. And we recognized about 2 years ago that as we get into the 5G, particularly 5G mmWave space, that it was really important to enable a set of ecosystem partners that can help customers get over that last hump in terms of whether it's EDA, whether it's packaging, whether it's test, whether it's IP or design services. Having that backup in being able to leverage for this marketplace, really, really important. You can see some of the key ecosystem partners here that on this particular page, and we continue to grow that partner program. RF-Wave has been a very great success for us, and I know many of our partners who work with us agree that this is a very rich ecosystem. In being able to deliver value-added services to our customers that is needed in this particular space. So a couple of announcements. I know you've heard some of these earlier today. Today we announced that we achieved more than $1 billion in design wins for our 45 RF-SOI technology. One of the things that I'll say is that there is no other technology that is more well published in terms of mmWave operation than 45 RF-SOI. I think all you got to do is go on IEEE Explore and search on 45 SOI, 12 S0, or 45 RF-SOI, and you'll see hundreds and hundreds of papers come up. It's been an amazing journey with this technology, and we're very pleased. And then the second one here, giving credit to our partner at mmWave, who did a press release with us in terms of leveraging our not only our technology but also our services to be a leader in the marketplace. And this just is a testament to the relationship that we build with our customers, and really trying to not only align them with a technology solution but also a deployment solution to get them out into the marketplace in a timely manner. So we'll talk a little bit about, I kind of gave a little bit of lead into this, but wanted to give a couple of success stories here with mmWave. We've had a long-standing relationship with mmWave for some time now. Really, started with the belief in the capabilities of our technology. Starting off initially with silicon germanium, and then moving to our other technologies. Really focused in the millimeter wave space and delivering on those technologies. But this is a customer that really took advantage of our turnkey services. This was something that they didn't have necessarily the capability or desire to do, and saw the value in what we brought from a turnkey perspective. We worked very closely with them on a packaging solution and an RF test solution, and are now delivering and winning sockets in the Tier 1 and Tier 2 space in 5G millimeter wave infrastructure. So those of you in the audience from mmWave, thank you very much, and look forward to continued successes in the future. Second one I wanted to call out, another success story, is our partnership and engagement with MixComm. This is a little bit of a Cinderella story in terms of we born and bred technologies like 45 RF-SOI in the university space, and we've had a long-standing relationship with many universities in 45 RF-SOI. In this case, Columbia, Dr. Harish from Columbia University, really incubating that technology and capability at Columbia, and then out of that came MixComm, and really delivering on the capabilities of the technology and delivering a solution that delivers very higher output power than CMOS and silicon germanium, leveraging the stacked PA capability that the technology is capable of, and really delivering on those promises in delivering on applications in the 5G millimeter wave infrastructure space. So those of you in the audience from MixComm, thank you very much, and really appreciate the partnership, and looking forward to many more. So just to wrap up. So, I left you with three things to think about this morning. One is, obviously 5G is rolling out, and we are seeing that with the engagements that we have in this space and all the customers that are engaged across our portfolio in 5G and millimeter wave, and really across a number of myriad of applications. The second, choice of technology is really, really important, and hopefully I've demonstrated to you what that can mean to you, and how you can deliver on an optimized solution for your customers in this market. And then third, GF has the portfolio of technologies that can deliver on this space, and it's not just providing a technology solution; it's providing a whole solution, and that includes the capability to do things like packaging and test, particularly in a space that is that can be very, very challenging. So when you're thinking of 5G infrastructure, I want you to think about GF. So thank you very much. Really appreciate your time today, and if you have any questions, please catch me after the presentation. Thank you so much.